Scientists at LIGO have detected the existence of gravitational waves. This is a tremendous discovery, and until recently, scientists didn't think we would ever be able to detect them, but that has now changed. So what are gravitational waves, and why are they so important? First, we need to go back 100 years, to 1916, when Einstein first proposed his theory of relativity. He predicted that anything that was accelerating could create gravitational waves. They can even be created if you jump up and down. However, these are so small that we wouldn't be able to detect them. Not yet, anyway. But a pair of orbiting black holes, 30 times the mass of our Sun, would send out a gigantic gravitational wave when they finally collide. Almost like an earthquake travelling at the speed of light that can stretch and compress everything it passes. Similarly, if I drop a fruit pastel into a bowl of jelly, ripples are created which bend and distort it temporarily, just as a gravitational wave does when it travels through space. Eventually, one of these ripples will reach our planet, and that is exactly what scientists at LIGO have been able to detect. And what's really amazing is that from the wave, they were able to deduce that the collision of these black holes occurred 1.3 billion years ago. That is way before the existence of dinosaurs or any other animals for that matter. But how did they do it? It's not like we could feel this gravitational wave as it passed through Earth. Scientists at LIGO developed two large detectors and placed them 3,000 kilometers apart, one in Livingston, Louisiana, and one in Hanford, Washington. The detectors consist of two arms placed perpendicularly. These are both exactly 4 kilometers in length. A laser beam is then shone onto a mirror that directs the light down the two tubes. When the light reaches the end of each tube, it bounces off before finally returning back to the start. Both beams of light return at exactly the same time, cancelling each other out. This setup is so sensitive that it allows scientists at LIGO to detect changes in the length of each tube thousands of times smaller than the size of a proton inside of an atom. So when a gravitational wave passes through, it stretches and compresses space, causing one tube to become shorter and the other longer, meaning that the beams of light now have to travel different distances, so they will return at different times and won't cancel each other out. This is detected by a machine that records light intensity and sends a signal that sounds just like this. Yep, that was the sound of a gravitational wave travelling through Earth. Scientists at the LIGO centres in Louisiana and Washington were both able to detect this signal at the same time, proving that a gravitational wave was passing through. So what does this mean for the future of astronomy and physics? Well, gravitational waves carry information about where they came from. So scientists can now listen to space to explore the universe even further than ever before. And if you want to help LIGO scientists, you can take part in their Gravity Spy program, in which you can identify real glitches in LIGO data to help them detect the next gravitational wave that passes through Earth.